So here's a solution video for IM2 day 7 problem number 6. We're given a parallelogram and we've got some information. They give us the sides. They tell us that there's this point F that's 5 units from S, which must mean that this distance is 3, just for later on. And then we're going to connect PF and SQ. We also know that SQ is equal to 10 centimeters. So they're asking us to find TS and TQ, which are these two lengths here. So first, it's important to note that TS and TQ are going to add up to 10. So I'm going to write that over here. So let's just write, first, we're given that these two are going to add up to 10. I suppose we're not given it, but we can figure it out really easily because these two chunks add up to SQ, and SQ is 10. So next we're going to have to use similar triangles, and I'm going to draw this out step by step because this is really important. To show similar triangles, so let's do a little similar triangles. There's a couple ways to show this, but right now we're going to focus on angle, angle, angle. So to show things are similar, triangles are similar, if you show they have the same shape, aka they have the same angles, then you're going to get that similar ratio that we like with similar triangles, and that's how we're going to solve this problem. So the first thing to do is find some triangles. If we suspect they're similar, let's just look at them. So I think that this triangle and this triangle are going to be similar. How do I know that for sure? Well, you've got to look at angles. So the easiest ones to find, I suppose, are these. And I put little dashes to show congruence. So those are congruent because they are vertical angles. Then, since we've got parallel lines, we can find some alternate interior angles. So this angle right here, I'll give 2 dashes to, is going to be congruent to this angle here. And this angle here is congruent to this angle here. So the different number of dashes show which is congruent to which. And if that part you didn't follow, review the parallel lines and transversal video that is uploaded. So the next thing we're going to do is redraw the triangles. Always, always, always redraw the triangles. And what I've done is, I haven't even given the vertices labels yet, but I've arranged it so that my angles are all going to line up the same way. So the 1 dash is at the top, the 2 dashes the left, and the 3 dashes on the right. So always make sure you do that first. Now we can label our vertices. So for the small triangle, that's going to be T, and it will also be T for the big triangle. The double dash in the small triangle is F. The triple is S. The double dash is P over here and Q over here. Now I've got my corresponding parts line up, right? The left side corresponds to left side, right to right, bottom to bottom. So you always want to do that, and you will make many fewer mistakes in similar triangle problems. So then what I'm going to do is label the sides I know. So I know FS and PQ. And now it's time for me to look at the parts of the triangle that I care about, which is ST, so right here, and TQ, which is here. So these two sides. So what I'm going to do is write an equation that has those two sides in it using my my ratio. So I'm going to write TS over TQ, right? Those are corresponding sides, is the same as 5 over 8. Since my triangles are similar, that ratio must hold, which gives me TS equals 5/8 TQ. And that's equation 2. So if you look at what I've come up here with, is there's an equation with TS and TQ as my unknowns. Here's another equation with TS and TQ as my unknowns. So yep, you guessed it, we're going to do a system of equations. So here's my system all set up, and you can replace TS and TQ with X and Y if you like, but then we're just going to go through. I'm going to do a substitution here, and we're going to solve for TQ. So here's my algebraic steps to find TQ, and then the last step is to find TS. So what we're going to do is just sub TQ in to one of our equations and solve. And that's the end of that problem. And you can double check TQ and TS do in fact add up to be 10, so it's a good way to check yourself. So for number 7, we're given a trapezoid. We're given the two bases, and then it says that we need to extend the non-parallel sides by a certain amount, and then we need to find how long the non-parallel sides are. So that's going to look like this. So I've extended the sides, those red dots, and they are going to meet at a point, and we know how far they extend, and what I'm going to do is just label some more things that I know. So I've just labeled some distances, and I labeled some points so that it's easier for me to name my triangles that I'm about to make. So this problem has some triangles hidden in it. We've got this red triangle with the green bottom, and then we've got the big green and red triangle. And it turns out that those two triangles are similar. If we look at this angle here, that's in both triangles, and it's going to be congruent. This angle, again, review your parallel line video because these are corresponding angles and they're going to be congruent. And likewise, this triple dash here. Those will all be congruent. So let's redraw our similar triangles. And here we go. Notice I've labeled all the angles and I lined them all up, so I know my ratios will be the corresponding sides I expect. And then we're going to set up ratios to find AC and AB, and then use that to find CD and BE. So here's our two ratios. I have AC, which is this side, over 9 is the same thing as, 18 over 12. And then I've got AB over 16 is 18 over 12. And then we're going to solve for AB and AC. So here are the values I get for AB and AC. And now we can use those because I know that AB minus AD is going to be the side I want, and AB minus AE is going to be the side I want. So let's go up here and do that. And after doing some algebra, you get these two values of 8 and 9/2, and those are our solutions.